Hello and welcome to Finding Regression Curves in Desmos. This is going to be a quick introduction to what a regression curve is, why they're important, and then how we use Desmos to create them. So let's take a look and first of all answer the question, what is regression? Well, if I have a set of data that looks like this and I want to find a relationship between those, I could describe the relationship in words. At first glance, it looks like the data is all over the place, but if I actually look closer at it, there does seem to be a general increasing trend in the data. So I could describe it in words that way. I could also come up with an equation that could represent these points. And maybe the equation doesn't exactly go through the points, but it's close. And that's the idea of regression, is actually coming up with that curve that's close to the points. Now, one way to find this close curve is I could just look at it and draw it. And the thing is, that's not very precise. If we had 20 people in a room and we all chose to draw a straight line through this data, chances are all 20 of us are going to have something different. So that's actually not the way that we want to do. Maybe our lines would be close to each other, but we don't want close. We want everybody to always come up with the same equation. And so regression is a more formal statistical process for coming up with that line. In fact, it doesn't necessarily have to be a straight line when we're doing regression. If we tried to eyeball it, we could come up with all sorts of different curves. So let's actually try to find the best curve that can go through this. And then once we do find that curve, like here's some data for should Scotland be an independent country, and they took a poll. And you can see these dots are all over the place. If we actually just try to look at the points and try to analyze the data that way, it may not be as clear what the data is telling us, but by coming up with these trend lines, it gives us a better way of talking about the data. And this is definitely more complicated than what we're going to look at today, but the idea is the same. And then once you also have a line and an equation, you can use that to make predictions for the future. And so that's what we'll be taking a look at. So let's look at this example here. Now I purposely left off what this data represents, but we've got some data. If I look really quickly at the independent variables, they are increasing. In fact, they're increasing at a constant rate. And while that's increasing at a constant rate, the dependent variables seem to increase and then decrease. So if values increase and then decrease, well, that kind of sounds like a parabola, doesn't it? I wonder then. Let's take a look at Desmos and help us analyze this data. So I'll just go to desmos.com and we'll click Graphing Calculator. And it opens up this. Now take a quick look here. We can see the X values are going from -10 to 10 and the Y values are going from -6 to 6. This is considered the home screen for Desmos, the home window. And then over here on the left, if I click on plus, for our purposes today, I want to make a table of values. In fact, I'm going to make the same table of values that are over here on this table. Now I could try to flip back and forth between the two and try to type in a 3. Let's see, it's 3 and 43 and 4 and 50. I don't remember what it was. We could try to do that. There's actually an easier way, especially if you have a lot of data. Typically when we have a lot of data, we're going to have it in Excel anyway. If I open up an Excel spreadsheet that I already had here, this has the data already in it. I'm just going to copy it. I just hit Control-C to copy it into the clipboard. If I go back to Desmos, I don't even need this table actually. I'm going to go ahead and hit this X to delete it. I don't need a blank table. I'm just going to paste. And notice it pasted the table in, it plotted my data, and look at my window. It's also changed. It's going from -4 to 16 and -40 to 120 on the Y. So it's helpful. Like it changed everything so that it set it up for what we need. So that Control-V paste is actually kind of handy. And then, yeah, look at that. It looks like a parabola. So it's super easy to go ahead and do a regression curve. Once we got our points, looks like a parabola, we're going to come up with an equation of a parabola that best goes through those points. If you think about the standard form of a parabola, y equals ax squared plus bx plus c. You can just type that over here on the left. except nothing happened, and it's giving me an error. Well, there's a couple reasons. First of all, it's got too many it doesn't know what A, B, and C are. It's waiting for us to tell it what A, B, and C are, but we actually want it to be the opposite. We want the program to tell us what the best values for A, B, and C are. That's regression. So to do that, instead of an equal sign, you change it to a tilde. And the tilde is actually next to the 1 button on that row of numbers on your keyboard. And then the other thing, I still have an error because somehow I need to tell it to look at this table. And notice at the top of the table, it's X1 and Y1. I need to change these to X1 and Y1s, not just X's and Y's. And that's super easy. I'm going to go ahead and just move my cursor to the right of the Y. I don't have to do any special combination of keys. I'm just literally going to hit 1, and it automatically makes a subscript. I'll do the same thing with the X's, and it automatically creates that curve. It's telling me what the best values for A, B, and C are to use, and it's drawing that parabola for me, and we can see, wow, look at that. It's actually going through the points really well. It's pretty good. How good is it, you may be wondering? Well, we can quantify that. In statistics, we have a coefficient of determination. That's what R squared is. And the closer this thing is to 1. R squared is always between 0 and 1, and the closer it is to 1, the better it is. And 0.9912, that's really close. So I could end the video here and just say that's how you find regression. But I do want to point out one little thing. I'm going to go back to the slideshow here. Here's the data again. But notice now I'm going to tell you what it represents. The data represents the highest daily temperature by month in the city of Syracuse, New York. So what do you think? Now that we're given more information, does it change what you think about our model that we developed? Why or why not? So I want you to go ahead and pause the video and ponder this question for a moment. All right, hopefully you did pause to think about it, and our table or our graph does not make sense. These are values for temperature. Temperature over time just goes up and down. We came up with a parabola that says the temperatures would start somewhere down from negative infinity. If you go back far enough, it's going to get really, really cold, and then in some random month it hit this high point, and then it's just going to continue to decrease forever. No, this is going to go up and down. And let's think about what kind of graph goes up and down. And hopefully you're already thinking about a sine graph. So let's go ahead and put a sine graph here. I'm going to go ahead and keep the parabola. Just to turn it off, all I have to do is click this circle over here. Turns off the parabola. I'm going to go to another blank line. Now, I don't want to use A, B, and C because A, B, and C have already been defined. So I'm going to have to use new variables. Also notice that it's talking about this residuals and using an E for that. Don't worry about residuals and what they are. That's for a statistics class beyond the scope of this class. Just know that they're there and they use an E. E is reserved for that. So we don't want to use E. And also don't use I because that's imaginary, and of course X and Y. So when you're coming up with values for these parameters, just use something other than E, I, X, and Y. So I want a sine graph. I'm going to do Y1 tilde, tell it to look up at the table and tell it regression. Normally I would put an A, but the next letter in the alphabet is D, so I'll use D, sine, and then can't use E, so F, X1 minus C, whoops, minus G plus H. And, oh wow, look at that. That's really good. That almost goes through the points. Not quite. In fact, if you look at my value for R squared, that is so close to 1. This is almost a perfect match. So there you go. Now we got our curve. Now I do want to show you really quickly how you can, a couple of other things. I'm going to go back here to my data for a minute. My original data just went from March to November. Let's go ahead and put these months in. Let's put January, February, and December in. So 32, 34, 36. That's really nice because we can go here to my table and I can just create new rows. It's okay if it's not in the same order. Now my r squared went down just a little bit, not much. My parabola isn't quite, let's see here, there we go. My parabola isn't quite as good anymore because I got those new values in, but it's not bad. It's not bad at all. Now the last thing I do want to do is just show you how you can make predictions. We have to define a new function. So I'm going to go ahead and copy and paste this. I want to go ahead and use D, F, G, and H. Those are already defined for me and I want to use that. I just need to change this to function notation. Normally we'd use f of x. F is already up here. It's kind of bad form to use it again for functions. So the next letter in the alphabet that I can use is J. So I'm going to use J of x. And I just need to change this to a regular x. And equal sign. It's actually graphing the same thing. If you notice, this is a red sign graph because this equation is red. If I turn it off, you can see this graph turn black because this equation is black. They're graphing the same exact curve. But now we can use function notation. I can say, what about January of the next year? You know, we could say 13. What about J of 1? And it makes sense. Those would be about the same. It's close. J of 10. So we can go ahead and now put these different values in. It will make predictions. So that's how you use Desmos for this. So some things to consider when you are using regression. Remember how we looked at the data first? I just quickly looked at the data, saw the independent variables were increasing, the dependent were going up and down. I was thinking at first a parabola, but then also think about the context of your problem and use that to also help you. So look at the data, try plotting it, see what's going on. Think about the context of your problem and what would make sense to happen, and then that will help you determine what kind of equation you want. Once you know what kind of equation you want, then the process of regression will come up with the same equation every time. So there you go, regression in a nutshell. Thanks a lot for listening and see you later. Bye.